Hey there, how's it going? Welcome back. New camera, hopefully it looks good, although this video will be pretty chart heavy. Anyway, you're here to see what performance modes are available on the EVO14-S, and you shall. But first, some quick updates about some other things with the laptop. Origin is sending me a replacement SSD to address the slow read performance I was getting with my unit, and a new screw to replace the one that got stripped. I'm also trying to figure out an issue I've been having where it won't go into sleep mode if it is connected to power. So hopefully I'll have more information about those for the full review. So performance modes. The EVO14 allows you to change the performance modes in a number of ways. You can toggle between 20 dB and balanced mode in the BIOS or with a hotkey, that's FNF5. You can also access these modes from the Origin Control Center that comes pre-installed on the device. From this control center, you can see that these two modes each have 3 different settings for an effective 6 total performance modes. You can also see that the lower mode is somewhat ambiguously named. It's called 20 dB mode, but it can be set to 20, 30, or 40 dB. And you can see that the formatting is inconsistent. More about that in the full review. For the purposes of this video, I will generally refer to the modes by their exact setting, and where needed, I will refer to the general 20 dB mode as quiet mode or quiet modes. Now, Windows also has 3 performance modes available in the battery settings. For the purposes of this video, all testing was in balanced mode. I did test all 3 in Origin's medium power mode with Cinebench Multi-threaded. Didn't find any significant change between the modes. The scope of this video is purely a test of the various performance modes while plugged in and fully charged. I do present some performance figures, but only in a few tests and with wide error margins. For the sake of my own time, these results are recorded from a single test run, and some are based on my own reading of instantaneous performance, power, or thermal readings, so they should be understood to be imprecise. This methodology may change for the full review, and thus any figures presented might also change. You should know that the EVO14 uses a shared heatsink with 2 heat pipes and liquid metal as the thermal interface, although I've not validated this claim as I'm not prepared to deal with liquid metal. The heat pipes go into 2 fin stacks, each with a blower fan that takes in air through the vents on the bottom panel and exhausts that air out the back, right behind the display hinge. This means some hot air is blown upward along the display panel and some is blown under the display hinge. As you can see, this airflow pattern is not super generous when sitting flat on a table, but is greatly helped by being propped up in the back. So in some tests, I've tested with the rear feet resting on my old laptop, which lifts it about 20 millimeters from the table and allows for significantly more airflow, both intake and exhaust. The power, clock speed, and temperature numbers you see in this video are from Hardware Info 64. Since it introduces a slight load on the CPU itself, I collected performance results on a separate test run without it running. In the Cinebench Multi-threaded test specifically, I noticed that between repetitions of the render, the clocks and temperatures would spike quite a bit higher, so I've specifically tried to exclude those time periods, only including data that was collected while actually performing the render. You should also know that for the CPU portions, I'm reporting CPU package power, CPU package temperature, and an approximation of P and E core clock speeds. For the GPU portions, I'm reporting GPU power, GPU temperature, and GPU clock. There is also a GPU hotspot temperature sensor, which typically reads about 7 degrees hotter, but I am using the regular temperature sensor as I think it is more akin to the CPU package temperature sensor. At idle, the CPU consumes about 2.5 watts and the GPU consumes 3.6 watts. However, the GPU does not activate at all unless there is an active application that Windows identifies as needing discrete graphics. In my testing, I've found that the FurMark launcher will activate the GPU but not require any actual work from it. These idle figures do not change based on the power modes I looked at. However, you should remember that in the higher power modes, momentary foreground or background tasks will be able to push consumption higher than in the lower, quieter modes. Now for our first real tests, let's look at CPU behavior in these modes with a Cinebench R23 multi-thread test. If you haven't used Cinebench or haven't in a while, you should know that R23 by default runs on a loop for 10 minutes, then completes the pass it's currently on. This means that every run is at least 10 minutes, but maybe several minutes longer. Intel CPUs like this i7-12700H typically boost to a certain power level for some time before settling in at a lower sustained power level. We see this kind of behavior in the balanced modes, but the quiet modes limit power so low that the sustained and boost power is the same. In the quiet modes, we see the CPU limited to 10, 13, or 15 watts of power. In the balanced modes, it is allowed to boost to 60 watts for under a minute, then it is limited to 20, 40, or 45 watts. As a reminder, the official Intel spec lists the 12700H as a 45 watt CPU and expects a minimum power of 35 watts, so it looks like the 12700H is technically only running within spec at medium or high power modes. This is particularly important to note if you are cross-shopping this with other 12700H laptops, of which probably most of them are at least a pound heavier. As you should expect, performance varies widely in these different modes as these different power limits are enforced. For some context, I've gone and cross-referenced my imprecise figures with more precise data from Hardware Unboxed to find other processors running at their normal power levels that match these various performance levels in the EVO14. Even in the quiet modes, it's outperforming Intel's old 11th gen U series parts, which isn't saying all that much. Keep in mind that in this test, the 11th gen i5s and i7s perform roughly the same, and looking at the power levels, you can see a notable improvement in efficiency. In 40dB mode, with a 15 watt power budget, it's close to the performance of a 15 watt Ryzen 5 5500U. It approaches the 15 watt Ryzen 7 5700U in low power mode using 20 watts sustained. Recall that AMD has been quite strong in multi-threaded tests for a while. In medium and high power modes, it pulls significantly ahead of its 28 watt sibling, the i7 1260p, and AMD's 25 watt Ryzen 7 6800U. These modes can also beat a 35 watt Ryzen 9 6900HS by a much smaller margin. However, in no performance mode could I quite match the figure Hardware Unboxed has for the 45 watt i7 12700H, with no significant performance difference when the laptop is propped up for better airflow. However, this discrepancy makes sense if I change Cinebench to only run one rendered test at a time, then run several back-to-back in high power mode. The first 3 runs match or exceed the Hardware Unboxed result, after which it stabilizes to about the performance that we saw from the default 10-minute run. So it can perform like a typical 12700H for a while, then it has to bring it down a bit. Let's look at efficiency in these modes computed by taking the Cinebench score divided by the sustained power level. For this metric, I'm ignoring the boost period. Here we see the best efficiency in the lower power modes. Efficiency is particularly relevant when operating on battery power, although I can already tell you that on battery power it does have lower power limits in the higher power modes, so I'll test this more for the full review. Here's a quick look at clock speeds, showing that in all balanced modes the 60 watt boost period allows them to boost to the same frequencies, but after that boost period you can see different sustained clock speeds based on the long-term power limits. Temperatures are substantially affected by the power modes. However, the other component of this is noise, since the fan curve is adjusted in the various power modes, which will be clearly demonstrated later in the video. The quiet modes keep the CPU quite cool, around 60 degrees. The higher power modes sometimes see the temperatures in the 90s, where T-junction for the CPU is 100 degrees. Assuming I'm reading the same sensor that enforces the T-junction limit, Origin seems to have set a fan curve that steers comfortably clear of that limit at the cost of noise. We can see that giving the fans more breathing room reduces temperatures by a few degrees, and you will see soon that this also allows the fans to run slower. Noise scales dramatically by power mode, as demonstrated by some audio samples I recorded about 5 minutes into a Cinebench run. In retrospect, I should have kept it recording while I stopped Cinebench, as I noticed that in the quiet modes the fans would actually spin up noticeably after I stopped the test. But as I've done more testing, including with the single-threaded render test, I've not really found why it was doing that. So it's a little complicated, but you should know that the fans may sometimes spin faster in these quiet modes. So here's some samples. In Cinbenech Single-thread, the same power limits are enforced, however the single-thread test never exceeds 25 watts, so all balanced modes boost to 25 watts and medium and high sustain that limit long term. I assume that since it pulls quite a bit more in a multi-threaded test, that this 25 watt limit is just because that's all the processor needs when a single core is being stressed. Performance scales not nearly as dramatically as in the multi-threaded test, which is consistent with the milder power scaling. 20 dB and 30 dB modes put it past the Ryzen 7 5700U and Ryzen 7 6800U respectively. 20 dB mode passes the i7-1165G7 while consuming less power. The balanced modes are able to pass the Ryzen 9 6900HS, with the lower power i7-1260P falling between the low and medium power modes. And high power mode performs like medium power with the 25 watt single core workload, ending up very close to the hardware unboxed result for the 12700H. Please note that for the purposes of this chart, I'm listing the modes by their multi-threaded power limit, as this should be more consistent with the power levels reported by hardware unboxed. Efficiency in the single-threaded test scales down more quickly than in the multi-threaded test. In multi-threaded, 20 dB through low power modes are pretty close in efficiency, while in single-threaded it falls off much quicker. The spec sheet has a maximum turbo frequency of 4.7 GHz. In the higher power modes, it is able to hit this speed, but it is neither able to exceed nor sustain it. Temperatures are interesting when you compare them to the multi-threaded results. Through low power mode, the single core temps are higher despite running at the same power limits. It does seem to make sense, however. In a multi-core workload, the heat load is spread across all cores that are doing work, but in a single core workload, the heat is concentrated in a smaller area on the processor. So while it's the same heat load, it's more concentrated and thus more difficult to cool. However, in medium and high, since it's using much less power overall than the multi-thread test, the overall temperatures are somewhat lower. Since it only requires 25 watts at most, the single-threaded test doesn't get as loud as the multi-threaded test, although I don't have audio samples for this, unfortunately. Let's look briefly at the CPU-Z benchmark, which runs much quicker than Cinebench. This means that in all balanced modes it completes during the boost period, meaning that even in the multi-threaded test there is no scaling in this modes to speak of. Because of this, I'm looking specifically at boost power to compute efficiency, which scales similarly to Cinebench in both single-threaded and multi-threaded test. Again, stay tuned for the full review for testing on how this influences heavy fixed CPU tasks on battery. Let's now look at how the RTX 3050 Ti behaves in the different power modes, which is quite different from how the CPU behaves. For this section, I'm looking at a 10-minute FurMark run at 1080p with 8x MSAA, and the performance endpoint is given by an approximate integer average frames per second. The scores are quite low, so the precision here is much worse than with Cinebench. This could be helped somewhat by decreasing the settings and getting the frame rate higher, but I stuck with 1080p 8x because I have several data points from other systems using those settings. Power level behavior is somewhat simpler than CPU power behavior. In all quiet modes, the GPU is given 35 watts, and in all balanced modes, it is given 45 watts. Note that the specs for the RTX 3050 Ti laptop GPU lists a power range of 35 to 80 watts, so it's always within spec but on the lower end. However, when the FurMark window is not the active window, the quiet modes drop down to 20 to 22 watts depending on the exact mode, and I did not see this behavior in the balanced modes. Naturally, all results aside from the background power levels were measured with it in the foreground. Performance figures do not show small differences due to the low frame rates, but you can see a clear difference in the quiet and balanced modes, and even some evidence of the different fan curves allowing slight changes to the clock speed, which also scales accordingly. The peak clock speeds are a little inconsistent, but the sustained clocks clearly show slight benefits to running in a higher power mode. Although it doesn't substantially change the overall power level, perhaps a fraction of a watt, it does change the sorts of clock speeds it's able to sustain. Since the GPU power is pretty consistent within the two general modes, the temperatures just show the difference in the fan curve in these various precise modes. Especially in the quiet modes, you see significant changes to GPU temperature as we go into the higher modes with more aggressive fan curves. Recall that I am reporting overall package temperature. The hotspot temperature will be about 7 degrees hotter. Fan noise, especially in the quiet modes, does not scale nearly as noticeably as in the CPU test because it just starts much louder. Have a listen. Now that we have a pretty good idea how the CPU and GPU behave on their own, let's see what happens when they're both trying to run to the max. This is with both Cinebench Multi-thread and FurMark going at the same time. In the quiet modes, the CPU is allowed the same power limits as when it is alone. In the balanced modes, it is only ever allowed to boost to 28 watts, after which it is not allowed past 25 watts. However, even in the quiet modes, the CPU is notably behind the performance it achieves on its own, so perhaps FurMark requires more CPU cycles than I thought. And in the higher power modes, it is much more significantly behind. In this performance scenario, it never exceeds the performance of the i7-1260P in Hardware Unboxed's testing, which does make sense as that part is rated for 28 watts, very close to the levels the EVO14 allows under these conditions. Temperatures are significantly increased as well. Although the CPU itself is never putting out more heat than it does on its own, the GPU is adding a lot of heat to the shared heatsink. Moving up to high power, the CPU is itself putting out much less heat, but the GPU heat brings it up to similar temperatures to the CPU-only test. GPU power mostly stays around 35 watts. In 20 dB and 30 dB mode, it stays there for about 5 minutes, then drifts down to settle around 25 and 31 watts respectively. Interestingly, the low power mode edged out the others to claim the highest GPU power in this scenario. During the CPU boost period, it was also at 35 watts, then hovered around 40 watts. This is why I have it notated as having a lower boost power than sustained power. My initial data had it hitting 40 watts only briefly, then settling around 36 watts, but in further testing it seems that that was just anomalous behavior. It does go down from 40 watts, but seems to take longer than the 10-minute test period to do so. Performance is notably behind, especially in the 20 dB mode and balanced modes. Note that I am reporting an approximate frame rate at the end of the test, not an average through the whole test, so that it's mostly reflective of what's likely to be the sustained GPU performance throughout a long gaming session. The dip in medium power might just be a slightly unlucky run. Certainly it should not be read into as a precise claim to performance, especially in light of other results later in this video. In GPU temperatures, we can see consistent increases across the board, aside from 20 dB mode, where already the 35 watts in the GPU only test was quite a lot for that mode's fan curve. Let's quickly look at the CPU and GPU power together in this test. Consistent with Origin branding this as a gaming laptop, the power favors the GPU, although both on their own can sustain 45 watts and only the CPU can boost beyond that. When they're competing for resources, the GPU is favored. We can also see combined power hit 60 watts, which is what the CPU will boost to briefly. Perhaps in CPU-only tasks in high power mode, they could have made the CPU settle in at a higher power level, but I'm perfectly okay with them sticking to and not exceeding the Intel spec. These power levels are not a lot for a normal gaming laptop, but they're a ton for a 2.5-pound ultra portable. So naturally, it requires the fans to spin very loudly to dissipate this heat load. First, let's take a listen just to each power mode in this test. Now let's compare it to the CPU-only tests. And last, let's compare to the GPU-only tests. The high power fan noise in this scenario represents the loudest that the fans should get during normal operation at about room temperature. However, the mode selection in the Origin Control Center also has a fan boost button, which just locks the fans to max speed regardless of detected temperatures or power mode. Here's what that sounds like. Let's now look at a different benchmark that I expect to be more reflective of actual gaming performance. That is, aside from the fact that a full test run completes in just a minute or two. Anyway, this is the Unigine Superposition benchmark. I'm testing 1080p medium in full screen mode for the performance figures, and in windowed mode as the active window for the power figures. The power figures for this are really interesting. Let's first look at CPU power compared to the Cinebench and FurMark run. In the quiet power modes, it boosts a little higher and settles in at a lower sustained power level. In the balanced modes, both boost and sustained are lower. Superposition uses some CPU resources, but is not nearly as CPU demanding as Cinebench, so these lower power figures seem to make sense. What doesn't make sense is why, in this clearly GPU-bound workload, the GPU is given less power in the quiet modes. It can always boost to 35 watts, but then it's brought down about 8 watts lower than it sustains in the Cinebench and FurMark test. In the balanced modes, it does go higher, and performance scales accordingly. Performance in superposition is given both as a score and as an average frame rate. These numbers are directly correlated and have the exact same scaling, so I've got the graph based on frame rate, but I also have the score listed. Performance scales significantly up to low power mode. After that, increasing the power mode further doesn't significantly increase the power levels, and thus any scaling at this point is statistically insignificant. Please note that this may not apply in all games, although looking back at the full stress test power levels, I would guess that even in a CPU-heavy game, performance is unlikely to change between high and medium power modes. Unfortunately, I haven't found much in terms of Unigine or FurMark results for other laptops, but here's where the balanced mode results sit in the 1080p medium Unigine leaderboards, with mostly desktops being listed here. It puts it near GTX 1066GB equipped desktops, which is consistent with a quick test run on my 1060 equipped home theater PC. There will be more comparisons to my home theater PC and main desktop in the full review. And of course, you can run Unigine Superposition on your own laptop with the 1080p medium preset and compare with these results. As I started seeing some of the data you've just seen, I started to wonder how much the discrete graphics was actually contributing to gaming performance over the integrated Intel Xe graphics. Fortunately, Windows 11 makes it quite easy to switch between integrated and discrete graphics for specific applications. So let's compare FurMark in a few performance scenarios, 30 dB and high power on both graphics processors, as well as the worst case scenario for the discrete graphics, which is 20 dB mode with Cinebench running as well. And yeah, worst case discrete beats best case integrated, and best case discrete nearly doubles best case integrated. And in the best case integrated scenario, the IGP does report the advertised max clock speed of 1.4 GHz with total CPU package power of 35 watts. We can also do something similar with the Unigine Superposition benchmark. Here we see best case discrete roughly triple the performance of best case integrated, so with the Xe graphics performing as designed, this laptop does benefit a lot from the discrete graphics, and even roughly 20 watts is enough for this RTX 3050 Ti to beat the Xe graphics, pulling 35 watts. So the 6 total power modes in the EVO14-S give it the ability to morph from a pretty normal ultralight into a moderately capable gaming or workstation laptop. Recall that even in the minimum 20 dB mode with 10 watts to the CPU, it can still exceed the performance of Intel's own last-gen 15-watt i7-1165G7. Or you can turn up the power and run the 12700H at the proper long-term power level of 45 watts, or anything in between. I haven't really tested battery life yet, but with the quiet modes, I can clearly see how they're able to claim 16 hours. These tests do demonstrate the importance of looking at performance figures specific to the laptop model you're looking at, as these same components in a heavier laptop will almost certainly have much higher power limits. Laptop manufacturers have quite a bit of leeway in how they configure the power levels of their devices. Even though this does run the GPU within spec, thicker laptops typically run their GPU well above the minimum power limit. So this will be outperformed by most other RTX 3050 Ti laptops, and probably a lot of RTX 3050 and GTX 1650 laptops as well. If you are cross-shopping this with thicker and heavier gaming laptops, you should expect them to perform notably better, or to perform similarly at a much lower noise level. Perfect example, the Asus TUF-15, currently just over $1,000 on Amazon. It's got a similar i7 CPU, but with an RTX 3060, and right on the product page, it lists up to 105 watts for the GPU. It's heavier, 4.4 pounds, but that extra weight allows it to have much higher power levels and much better performance. And if you have the option to set similar power limits to what the EVO14-S runs, the bigger cooler will require less airflow from the fans to dissipate the heat. The EVO14-S is a great performer for an ultra portable, but pretty weak and pricey for a gaming laptop. If you get it and intend to game on it, you should plan to do so with closed back headphones with good noise isolation and in situations where others will not be particularly bothered by the loud fans. Personally, since I was mainly cross-shopping this with 15 to 25 watt ultralight laptops, the performance in the quiet modes is plenty most of the time, and the noise in those modes is potentially quite a bit better than the other laptops I was considering. I expect to primarily keep it in 30 dB mode, switching into low power mode if I want to do some gaming or other heavier tasks with it. Since mixed workloads don't allow much additional power beyond low power mode, I figure I might as well target a slightly less loud experience. Now, I don't intend to do much CPU heavy work with mine, and I intend to keep it at or below low power mode, so I would not have cared if they just put a lower power P or U series CPU in here, and I might prefer it if it enabled it to be more power efficient. That said, looking at the performance in the various power modes, running the 12700H at these power limits doesn't seem to compromise performance much anyway. So I think that's about all there is to talk about for now. Remember, this is not a full laptop review, only a dive into the performance modes available and how performance, power, thermals, and noise scale accordingly. For the full review, I'll present more performance tests, but probably only in 2 or 3 of the modes available. Let me know in the comments if there are specific tests or modes that you want to see more of for the full review, and I'll see what I can do. So that's it for now. Let me know what you think in the comments down below, and I'll talk at you in the next one.